Today, we're going to pull back the curtain on this invisible rule that honestly keeps our entire high-tech world from shaking itself to pieces. It's a huge safety principle in engineering that you've probably never even heard of, but it is working all around you every single day. So let's get into it.
I mean, seriously, think about it for a second. You've got everything from a massive jet engine to the little spinning drum in your washing machine. What's the secret sauce that stops them from vibrating so violently that they just, well, self-destruct? Turned out, the answer is a really brilliant but simple piece of engineering logic. So, to really get how they solve this, we first have to understand the problem itself. And the problem is this hidden danger zone that exists inside every single object that rotates.
You know, it's kind of like pushing a kid on a swing. If you time your pushes just right, if you match the swing's natural rhythm, they go higher and higher with almost no effort. Well, a machine is basically the same. It has its own natural frequency, and if you hit it, even tiny vibrations can get amplified into something really powerful and really destructive.
And this whole phenomenon, it has a name. It's called resonance. It's the science behind that swing example, and for a mechanical engineer, it is public enemy number one. When a machine hits resonance, its vibrations can just spiral completely out of control. The results can be catastrophic.
Now, this dangerous vibration point, it isn't just some random thing that happens. In the world of engineering, it has a very specific name, and knowing that name and that number is the first step to preventing a total disaster. And that name is critical speed. It's the exact RPM, revolutions per minute, that an engineer has to avoid at all costs. Hitting that speed is like plucking a guitar string at its perfect pitch, except instead of a nice sound, you get vibrations that can tear a machine apart. This chart really lays out the whole challenge. You've got the critical speed, that big red bar, the danger zone you absolutely cannot enter. And then you have the machine's normal operating speed, which has to stay way over in the safe zone. The whole game is just keeping those two as far apart as possible.
But that's the big question, right? How far is far enough? And that brings us to the real hero of our story today. This simple but genius principle that guarantees everything stays stable.
This is so important. You can't just design a machine to run at a speed that's, technically 1 RPM below the critical speed. That's not good enough. Even getting close to that danger zone can cause all sorts of instability and bad vibrations. You need a buffer, a real buffer. In that buffer zone, it's got a name, and it's the big takeaway for today, the safety margin. It is the deliberate, intentional gap that engineers design between how fast a machine works and how fast it could destroy itself.
So how does this actually play out in the real world? Well, it's not just a guessing game. Engineers use a very precise rule to figure out this margin and make sure a machine is going to be rock solid.
Let's use a real-world number to make this concrete. Okay, imagine a machine that's designed to run at 730 revolutions per minute. That's its normal job. The engineer's task is to make sure that 730 is safely inside the margin.
And there it is. That's the actual rule of thumb they follow. The working speed can't just be lower than the critical speed. It has to be lower than 80% of it. That other 20% that's left over, that is the safety margin, explicitly designed right into the system.
So the safety check becomes this really straightforward 3-step process. First, you figure out the machine's natural danger zone, its critical speed. Step 2, you do the math. You multiply that speed by 0.8 to find your absolute maximum safe speed. And finally, step 3, you just make sure your actual working speed, like our 730 RPM, is comfortably below that line. So you can see it's this constant balancing act. On one side, you have the operating speed. That's where the machine gets its work done. And on the other, you have the critical speed, the big red danger zone. The relationship between them is simple, and it's totally non-negotiable. The operating speed has to be kept way lower to keep things stable and prevent a catastrophic failure. Okay, let's zoom out a bit, because this isn't just about one machine or one specific number. This whole concept is one of the absolute pillars of modern engineering. So, let's do a quick recap. Every rotating thing has a natural frequency, and if you match it, you get resonance, which is bad. The exact speed where that happens is called the critical speed, and to stop that disaster from ever happening, engineers build in a safety margin, making sure the machine always runs at less than 80% of that danger point. It's a simple idea, but it's what keeps our high-speed world running safe and sound. And that kind of leaves us with one last thought, doesn't it? This whole idea of building a buffer zone to protect against a known point of failure, well, that's not just for spinning machines. It's in the bridges you drive over, the airplanes you fly in, even in the software on your phone. So next time you see something working perfectly, just ask yourself, what's the invisible safety margin that's making it all possible?